My name is Mr. Musser. I'm here at the beautiful Oregon Caves National Monument and Preserve to teach you about some science. Video, we're going to talk about plate tectonics. To demonstrate what they are, we're going to start with using a tomato, and we're going to wrap it with Play to represent Earth's crust. So you may think under the soil and rocks and the oceans that it's just one big rock under the Earth. But in fact, this isn't how it looks. So now we're going to use some different color Play-Doh to show you how plate tectonics work and look. So this is what plate tectonics are. They are pieces of the crust that are broken up like into several different puzzle pieces. There are 8 major pieces that have been identified with several other smaller ones. Now they are constantly moving. This is called continental drift theory. That was first hypothesized by Alfred Wegener back in the early 20th century. So they are constantly moving, which causes different type of reactions depending on how they move. So we're going to take a closer look at the 3 different type of movements that these tectonic plates can do. So the first plate tectonic boundary we're going to talk about is called a divergent boundary. Now in math, you divide, which means splitting things up into groups. Divergent boundaries are similar. That's where you have 2 tectonic plates that are moving apart in opposite direction. They're splitting apart. So I have this foam here to represent that. So with a foam, it's going to move apart in opposite directions, and it's going to leave a gap. This gap's going to have to fill in with something, so what comes from up beneath the Earth would be magma. Now I don't have magma with me, so I'm just using these old pieces of wood to represent the red magma that comes up through the crust, Earth, into between the gap here. This creates new crust for the Earth. It's going to continue to split apart, and more crust is going to fill in the gap. Now in the middle of the ocean, which is where this commonly occurs, it's going to create a mid-ocean ridge. Now this sometimes occurs on land. A well-known example being Iceland. It's a big divergent boundary that's splitting apart the country, and it's slowly splitting into 2. This is just one of 3 examples, so let's move on to our next one. So our second type of plate tectonic boundary is called a convergent boundary. So divergent, they were splitting; convergent, they're going to come together. Now, a couple different things could happen here, so we're going to do 3 little demonstrations, depending on where the Earth this plate tectonic boundary is. Now, if they're both on oceanic crust, you would see 2 ocean crusts coming together, and then they could typically bend down to create an ocean trench. So also with convergent boundaries, if you have 2 continental plate boundaries coming together, you can create mountain ranges because they're going to come together and fold and bend upwards. So the last thing that can happen at a convergent boundary is when an oceanic plate meets a continental plate. So I'm not using the foam anymore, I'm using a pair of jeans to represent the oceanic plate, because oceanic plate are typically thinner, denser and heavier rocks, while the continental plate is usually consisted of thicker, lighter, less dense rocks. So what happens when they meet each other at a convergent boundary, the jeans, or the oceanic plate, will be pushed under, and it'll create what's called a subduction zone. What's called a subduction zone.
Subduction zone.
So in the subduction zone, the old oceanic crust will be melted and heated, and it'll rise to the top as magma through the continental crust, and then what you will see appearing are a range of volcanic mountains. So our third and final type of plate tectonic boundary is called a transform, occasionally called a sliding boundary. So with this boundary, this is when the 2 plates are moving side by side in opposite directions. Now it's not always a smooth sliding action. Sometimes they will be stuck next to each other for a while, pressure will build, and at one point they'll release the pressure and jolt a little bit, and this would cause earthquakes, what we feel, up on the surface. So in today's video we've been talking about plate tectonics and how it's been affecting the geology around the world. Now I have Ranger Kate here, and she's going to connect plate tectonics to what's happening in Oregon Caves and the region on the preserve. So Kate, what can you tell us about plate tectonics in Oregon Caves?
Well, plate tectonics is a pretty simple concept that there's a bunch of hard crust and rocks, surface rocks on the outside of the earth that are moving around and are pushed around by heat on the inside of the earth. And the rocks here at Oregon Caves are experiencing this right now. We're nestled inside the Siskiyou Mountains, and here inside the Siskiyou Mountains, we're still being uplifted thanks to plate tectonics. And the uplift is happening through convergence, where plates are crashing together and some are moving underneath other plates. And these plates are changing the rocks, change the marble here at Oregon Caves, and help to form the caves that we're in right now.
Thank you, Ranger Kate. I think that helped connect everything, bring it to a close. And that's going to be it for our video today. Thank you very much.